Hello, everyone. Welcome to Cloud on Air, live webinars from Google Cloud. We are hosting webinars every Tuesday. I'm Ricardo. I'm the lead for G Suite front-end security.
And I'm Alberto. I'm a manager within the counter abuse team.
Today, we're going to dive deep into Gmail, and we're going to talk about how we protect users against malware, ransomware, spam, and phishing. While we do the presentation, you can leave questions in the platform. And at the end of the presentation, we're going to answer a few of them live. If we don't get to your question, don't worry. We will answer them later in the platform. So here's what's going to happen in the next 30 minutes. So first, we're going to talk about the major threat vectors that are in scope for this presentation. We're going to present several techniques to address these threats. And in particular, we're going to see how AI can help detection. And finally, we are going to put it all together and see how all these techniques are used effectively to protect users. And then, as I said before, we're going to have a short Q&A where we answer your questions. So here's the threat vectors. We considered 4 for this presentation. The first one is spam, right? Spam is just unsolicited promotional messages. We've all got a lot of them. They are ubiquitous. They are not a threat per se, but if they're not kept in check, if the number is not kept in check, then it becomes a significant drain on the user's time and resources and so on. I think recent estimates put the damage due to spam in only American enterprises at about 20 billion per year. Then there's phishing, of course. Phishing messages impersonate legitimate email communications, and they trick the user into giving out their credential to the attacker, to the phisher. So most of them, the one that you might have also gotten in your inbox, they are large-scale campaigns. So you will get an email that says, please click here to reset your PayPal password. These are sent to millions of users. But it's also important to talk about spear phishing, especially in the context of the enterprise. These are targeted attacks that use information about the user, about the victim, to be more effective, and also evade a lot of defenses based on trends and large numbers because they affect a single user. Then there is malware, right? So malware is just a malicious payload that is delivered via various means. They run with full privileges on the user's machine, so they can do pretty much whatever they want. Lately in the news, we've seen ransomware. It's been very popular. So this variant of malware will encrypt your data and then ask for a ransom to decrypt your data and give it back to you. But more traditionally, malware has been used to get a foothold into organizations. That's very common. So the so-called advanced persistent threat, putting malware in one generic user into the organization is a good way of then expanding your access in the organization and staying undetected. And then there are client attacks. So these are exploit vulnerabilities in clients and web applications. And they execute code on the victim's device. And depending on the type of vulnerability, it could lead to the same kind of infection that you get from malware. Now Alberto is going to describe some techniques that we employ to mitigate these threats.
All right, so yeah, we enumerated a few of these attack vectors, and well, we'll take a quick tour of techniques that we see these abuse actors to deploy these attacks. And consequently, we'll talk about what we do to detect them, predict them, and make sure that we minimize the effect that they have on our users. So this will give you a glimpse of what our team does, why it's a hard problem, and also maybe it will give you some insights into what to do to prevent. There's a human factor always present, and want users to be aware and never let their guard off. So We'll go through some of these techniques, some of these attack vectors. Like I said, there's too many of them to cover in this talk. But we'll mention some of these, and hopefully it will give you an idea of what we see and what we do. Right. So first thing, I want you to imagine that there were no spam filters, right? And there's something that's someone that's sending you an email that you don't like, right? So you didn't like it the first time, don't think much of it, but then you keep a counter, right? Like you receive it for a second time, maybe a third time. You notice that these are all sent by someone, let's call them Bob, right? Well, what you might do if you have the ability to write some rule, right, would be to like say, if the email is coming from Bob, then let's mark it as read, delete it. put them in some other folder. Well, that's more or less what we do when people mark emails as spam, or we find out through other means that an email is bad. We extract several features from the email, and we keep account on how often we see bad emails versus good emails showing those. You see here on the screen some examples of some of those features. The obvious ones are the IP address, the email address of the sender, and then more aggregated features like, well, Class C networks or domains, TLDs, stats like the length of the message, words that are mentioned, colors, aspect ratios, you name it, right? And what we do is we keep a counter, keeping a tally of how often we see values of those features associated with badness. Now, if you want to take it a step further, you can combine this. Say an IP address is sort of bad. You've seen a few of them, maybe 20% are bad. Like it's hard to take and just put them all in the spam folder, right? So what we do is combine them, right? Maybe you see a partly shady IP address, but the domain is really bad, right? Maybe those two combined can be enough evidence so that you can send an email actually to the spam folder. Now, an even more powerful technique is if you can combine those features before you do the aggregation. So now you're tracking how two specific values of a feature together are related to badness. So now we see what values specifically coming from one ISP and containing specific words, how often those two together are related to badness. Now, if you're doing the math, like imagine you have like 1,000 of these features, pairwise combinations or tuples of more than those. It could clearly explode. If you multiply that by all the possible values, there's no way we could keep track of that. So I guess part of the secret sauce that we have is figuring out which of these to track over time, how to evolve them, and make sure that we keep the set that gives us the most return, right? Now, if you're the person who's sending you these emails is persistent, they would probably be aware that you blocked them, and they will try to change and go around your filters, right? Nowadays, it's easy enough to just get a new IP address, getting a new email address. So what we want to do is just make it a little bit harder for the abusers to go around the protection. So protection is great, but we need to figure out what aspects are hard for the abusers to go around and which ones they can just circumvent easily. So that prompts the question of like, what is it that, for example, let's focus on phishing. What is inherent to phishing? And it has to deceive someone, right? It has to prompt them into clicking in this link, disclosing their password information, executing a file, and so on. So one way to give legitimacy to that is to pretend to be someone else, right? An authority, someone with a lot of money, a business partner of your organization, depending on how much they know about you, right? And we see, like the example you see on the screen, someone might be pretending to be Google Tech Support. Now, if you just straight out say Google Tech Support, right, it's easy for us to catch that. So we'll try to do something that's called spoofing, which means you write some sentence, some word that can be interpreted as something, but literally doesn't say that. So you can, I don't know, replace zeros for O's. You can use what's called Unicode homoglyphs, which are characters that look exactly the same, that maybe characters that you're used to saying, but they're not the same characters. So any naive matching algorithm would miss them. So of course, we need to be aware of those and check for similarity. We use canonicalization of strings to bring them back to a form that can be compared. And there's a whole spectrum of sophistication, right? Like, so in the end of more sophisticated attacks, you can see even attacks where they target a specific, say, brand of smartphone, where that font makes like two V's together look like a W, but not in others. And then that makes, even though that narrows down the spectrum of victims that can fall for this, it also makes our job a little bit harder, because now you have to pretend or try to render these things in different platforms. So you can see how this thing is not that easy to scale. What they will also do, of course, is do this spoofing not only in the display name. They will use sometimes they will put an email address in the display name because you cannot easily spoof the email address. But if you put it on your display name, pretending that that is your email address, you could do it. Of course, we try to detect that. You could also put strings prompting you to click on this or to inherit this sum of money that we can also detect, so they try to spoof that. Now, as things get more sophisticated, they move from like character level spoofing to images. Which brings us to the next topic, right? Like one way to also, again, give legitimacy to this deceitful message is to provide the same visual similarity or visual theme of a legitimate email, right? Now, you might just toss a logo in there. Again, pixel by pixel, is pretty easy for us to catch, but of course, it's also easy for them to circumvent. You just randomly change some pixels, maybe like color distances that are hard for the eye to catch, and then that forces us to make some more fuzzy matching. Then you can change the fonts. You can do stuff to trick the filters. So we've been moving over to machine intelligence. So when we talk about AI, we mentioned this to check whether a logo is sufficiently similar to one that we are trying to protect, and even the layout, the fonts, the placement of the buttons, the overall colors. Now, just the fact that something an email looks like a legitimate one from another brand doesn't mean the email is bad, of course. So again, with the feature reputation case, we combine these things with others so that we accumulate enough evidence to decide whether an email is good or bad. Now, about visual similarity, we have to say this. We even see cases where there is no additional visual indication or advanced logos, just with the text. They're still able to trick some users, so nothing replaces, if you're a domain administrator, nothing replaces a good policy of keeping users aware and constantly reminding them to keep their guard up. The last technique we're gonna cover is about malicious attachments, right? Again, just like any antivirus check, we do checks on files because files can be used, as Ricardo mentioned, to create a botnet and have your computer join someone else to launch attacks against even other organizations. They can install software to watch what you're doing, either to get your credentials or just for espionage, and they can use ransomware. So there's a whole spectrum of bad stuff that can happen once they get a foothold into an organization's computer, right? Even if it's someone not that consequential in the organization for like financial purposes, they can use that to get to the person who controls the accounts, to the CEO, get information, and do social engineering and so on. So we definitely want to do all we can to prevent these things from ever being able to be executed. So Gmail outright disallows some types of attachments from being present, but spammers have other ways to do this. They can take advantage of traditionally non-executable formats like documents. We use PDF here as an example, but there are others where you can embed any binary object, right? There's also more shady ways of embedding, like executing macros requiring the user to interact with the document in some way to launch these macros. They will even download the content dynamically, so they can keep updating this and changing it so that the virus signatures don't match. So together with advanced techniques for extracting these embeddings, we need to apply techniques for like sandboxing, where we can execute these things in a restricted environment, and we can monitor whether they're trying to go home for a command and control center or trying to access your files to encrypt them in the case of ransomware, and so on. So Google has a range of signatures that we match against for regular AV, but we do all sorts of prediction and these sandboxing techniques to also apply to new cases that we've never seen. We have to say also G Suite offers configuration options. If you are a domain administrator, we recommend you to keep in touch with configuration options, familiarize yourself with them, and determine what their level of comfort it is according to the tier of the product that you have. and the risk aversion versus how much you want to delay messages because you want to scan them or get them immediately delivered to the inbox. Now, given the sheer scale of email, and frankly, the sheer scale of spam, which both range in the billions per day, and the time that this platform or this medium of communication has been around, as you could probably imagine, there's a huge amount of knowledge accumulated over the years for classification of spam that would be very hard for us to maintain as a list of just rules, right? Like getting rid of the old ones that are not useful anymore, merging ones that have like almost the same. It would be a pretty daunting task. So AI is a foundation that lets us do several things. One of them is serve as a repository of knowledge that is constantly being updated, and things that are not relevant anymore get taken out as part of the training process. Artificial intelligence and machine learning models in particular also adapt over time. New things, as long as you see them in the field, the systems will learn to recognize it. And lastly, depending on the technique you use, they also have the capability to predict. So you show them examples you've never seen before. There's a possibility you'll still catch them. We want to exploit that, and that's why we keep continually trying new methods that will allow us to be more proactive. So in general, AI enables Google to, well, protect users and against abuse. We also do recommendations and all other cool stuff with machine intelligence. But in the case of Gmail, we were one of the early adopters within the organization to harness the power of AI. But over the years, we built like a pretty good mix of traditional proven techniques and more like sort of cutting edge newer technologies. We have a pretty significant linear regression classifier model because that's what we started with, and we'll still keep it. But over the time, what we've come up with is a multi-layered, multi-pipeline setup. And by multi-layer, I mean take a convolutional neural network that you use to recognize visual features in something, a logo, or the presence of some particular graphic elements. That in itself usually won't be enough to classify something as bad. So that is, again, one more feature that we can extract via machine learning to determine, yes, there's a logo, there's not a logo. Then you combine that with other features, and you can feed that into either manual rules or more likely to another model. So we have multiple layers. And we have in parallel these parallel pipelines in such a way that even the final verdict we can get from multiple master models, so we can put them against each other, make sure that we're getting the best of both worlds. You can get like a second opinion of sorts, if you will. So the machine intelligence landscape is one that you have to keep continually maintaining. Now, it would be great if this would maintain itself. It's not so. So our team needs to keep continually adapting the training of the models, monitoring how well it's detecting what it's supposed to be detecting, and checking against new attacks. So some challenges that we find is, well, it starts with the training, right? You sample specific instances of both malicious emails and good emails. You need to teach the system to recognize both with the right set of features. You need to make sure that they're labeled correctly, right? You cannot take every spam mark as face value. You have to do some sort of cleanup and make sure that those run reliably and constantly, that you're able to train your models with enough cadence, be that every month, every week, every day, or maybe continuous learning models. You have to get into that cadence to make sure that you're constantly discarding all information, incorporating a new one, keeping your model tight and optimized. Another aspect that is particular to spam is that not everyone agrees on what is spam, right? Like what for some person might be completely undesirable, for some other it might be a mild annoyance, from some other person might be just like useful advertising that they happen to read every once in a while. So it will be pretty hard for us to keep like personalized, fully fledged machine learning model for every one of our users. Like, after all, these models do take up space. But luckily, you don't have to do that. There's a big section of the email spectrum where you can pretty much agree that they're good, that they're bad. We can keep the gray area as a parameterized option where you can feed it along with other signals. You can tell your model, okay, these are the features coming in from the email, but these are also the preferences of the user, so that you can adjust your thresholds and make the best decision for each of our users. Now, another challenge is models will make mistakes. You need to have a strategy to deal with those mistakes, to treat them differently depending on the type of mistake there is, and to systematically diminish them over time. It is true that models, like I said before, they will adapt over time and they will predict new situations, but when they fail, typically they don't recover instantly, right? It will take time for them to catch up. That means we do have a rules engine, blacklist, other like maybe less sophisticated techniques, but you need those to account for those gaps. Now, we talked about errors. Errors are not the same, right? Errors are, there's different types of errors and there's different like problem spaces. Take spam, for example. If we miss a spammy email ends up in your inbox, it's an annoyance. You might not think that much of it and like maybe delete it. Hopefully you'll mark it as spam and help us learn. But maybe that's the end of it, right? But on the other end, if we take a good email and put it in the spam folder, that might make you miss something important for your business. It might make you miss something important from someone you know, and so on. So clearly, they're not the same, right? For phishing, it's kind of the opposite, but not quite. Say, if we send something to the spam folder thinking it was phishing and you miss it, yeah, we already established that is bad. But if we really miss a phishing email, put it in your inbox, and you execute that, the potential like for disaster is much bigger, right? So there's really no good or bad error in here. There's still imbalance, but both are bad. So what we do in that case is we try to mitigate the effects of these errors by having what we can call softer hammers. Like in the case you're not completely sure something is a phishing email, instead of sending it to the spam folder, we can put some warnings in place, some UI hints, and Ricardo will cover some of those so that if you're a domain administrator, you can keep your users aware and always on the lookout for these signals. How this all looks together, like I said, over the years, we have a pretty significant linear classifier. So of the 99.9% of spammy and harmful email that we detect, about 9/10 of that is already caught by this classifier, right? But of the rest, of the remaining percentage, about half of it is heuristics. That means this rule engine that I was mentioning earlier, and the rest is for with more advanced machine learning techniques. Now, this is not the full picture. This is not like disjoint sets, right? Like there's a lot of overlap. We try to maximize that overlap. Actually, that's by design. This is a concept called defense in depth. If you want to get through our defenses, you should always need to break more than one thing, so that it's not easy for you that you just like hit the jackpot on one thing and then you're in, right? So, so what we see here is only additional coverage, and we would like to keep that small so that there's no single point where you can just like trick our defenses and get in. That question mark you see there is, of course, next generation. We're always investigating new techniques. They might be high or low tech. They might involve machine intelligence or not. We're constantly deriving new features, pushing for new standards, and then we can use to protect the identity or the integrity of emails, and so on. So that's like a constantly evolving field. So next we'll go to see how we perform the classification and what it ends up meaning to our users and how can identify what happened within the classification process.
Okay, so Alberto has shown all these powerful techniques, AV scanning, how the spam classifier works. So how does Gmail put it all together to protect the users against these threat vectors that we presented before? To explain that, I think it's easy to just go through the flow of a message from the sender to the user, to the end user. And we're not talking just about going from the outbox of the sender to the inbox of the user, but we'll also consider how the user interacts with the message once it has been delivered to the inbox. Okay, so in particular, we are interested in what happens when the message is malicious, of course, because if our purpose is to showcase the defenses, hopefully nothing happens if the message is benign, right? So we are going to see how a malicious message flows. We're going to see the life cycle of a malicious message. And here are all the relevant steps in more detail. They are sorted in temporal order. So on the left, you see delivery, which is the first step, and then all the way to the right, you see that actions that are taken by the user on the email, because you assume that going from left to right, you already opened it and everything, right? We are going to go through each one of them in detail, of course, because there are many. Okay, so note that something that is not shown in this flow is that delivery and sync, the first two phases, happen on the server. So they will be able to use all the intelligence that Alberto talked about. All the other phases happen on the client. Also note how reclassification is not quite defined in a single place in the order. That's because by definition it can happen at any time. Reclassification is the process of rerunning, of rescanning old messages with updated rules, updated AV signatures, and so on, and changing the verdict of the classifier and syncing the information to the client. So this can happen at any time or not happen at all, right? This can insert itself into any moment. Okay, so here are all the defenses, right, that we provided during the life cycle. So Alberto mentioned before about the spam classifier, the defense in depth, right? This is another example of defense in depth. So as you can see, to flow from all the way to the left to all the way to the right, you have to go through a lot of these defenses. So there's multiple layers here too. So if you are overwhelmed with the amount of red crosses and names on the slide, that's perfectly fine. That actually was intended. This slide is meant to be overwhelming because it gives me an excuse to now go through all the various phases and explain how all these defenses affect the delivery and an ongoing attack, right? When it comes to malicious email. So the first phase is delivery. This happens when we receive the message in our mail servers, but we haven't delivered it to the user yet. And in fact, we might not deliver it at all. So a lot of the spam messages, or spam phishing, malware, whatever, that never makes it to the user's inbox or even the spam folder. So we don't just decide whether we send an email to the inbox or the spam folder. We can also reject it altogether. If you think you have a lot of spam email in your spam folder right now, imagine if you had 10 times as much. That's more or less, I think, an approximate figure about how much we reject altogether versus what we put in spam. Note that most of our detection capabilities are here. As I mentioned before, this is one of the phases that happen on the server, so this is where all of our intelligence are available. The later phases will basically use metadata that has been generated here and use it, because now when you're on the client, now you can have user visible effects beside rejecting. The most common bit of metadata to give an example is, of course, the spam bit, right? Is it spam or is it non-spam? So does it go in the inbox or does it go in the spam folder? But there's other pieces of metadata that we're going to show. So this is the second phase is sync. So again, we're going to skip reclassification because it doesn't actually have an order. The second phase is sync. This is when the servers push the message to the client, so that then it becomes available to the user and he sees it in the thread list, in the list of unread messages. From a security standpoint, we need to do two main tasks here. Right? So the first one is to propagate all this security-relevant metadata that I mentioned before. So that way we can implement client-side defenses. The second main goal is to sanitize untrusted content. Right? The main purpose here is to sanitize the message body, which of course the email protocol doesn't define anything related to what kind of malicious content can appear in the body, how much the HTML can be dynamic, and so on. So we do have a very strict policy about what can be served on the user's device. The idea is that the server does the heavy lifting when it comes to sanitization, right? So the client gets a piece of HTML that is already safe to display. And then we have message open, right? So this is the phase that happens when the user, assuming the user selects a message, opens it, and now can see its contents, right? So this is a good place for us to give visual cues about security issues. So we can inform the user about something that is maybe relevant, or warn the user about something that is definitely suspicious. All these cues are about those gray areas that Alberto talked about. Like if an email is definitely malicious, then it wouldn't get here. But there's a long tail of emails that have some suspicious behavior or features that we cannot quite put in the spam folder. So this would be where we start warning the user, right, from now on. One example is, of course, showing a warning banner, right? So a banner that says, look, this could be phishing. These words were often associated with phishing, so be careful. Another example of a visual cue here is an up-to-date virus check. So we reissue a virus check, the same thing that has been done during delivery. We redo it when the message is open. And the reason why we redo it is because potentially the AV has been updated with signatures, and the AV could give a different verdict. Reclassification is supposed to take care of that, so we do have eventual consistency. Eventually, reclassification will do it even when the user doesn't open and push the update. But the issue is that reclassification is a background job that could take minutes to execute, and the idea is we want to close this window vulnerability. As soon as the AV has a new signature, it should have a visible effect on the user's inbox. So in that case, we would warn the user and prevent the download. After the message is opened, the user is going to interact with it, right? And depending on what type of threat we talk about, if it's phishing, malware, and so on, we focus on different actions, right? If your message is carrying an exploit, then the most relevant phase is the download of an attachment. So let's go through a scenario where the user sends a malicious PDF that is supposed to exploit Adobe Reader vulnerability, right? So the first phase is that maybe nothing happens at all, right? Because as you saw before, during delivery we could reject the message. So Gmail the user might not see that at all, right? The inbox is still empty because the email was never delivered to the user. So let's assume, again, defense in depth. So let's assume that one layer fails. The message gets through because the AV signatures were not up to date. This is a very novel threat that our AVs couldn't handle. So the user then sees the message and decides to open it. So all is not lost, right? So we have a few extra additional layers of defense. For example, we have not just a virus scanning, but we also have a lot of heuristics regarding what is risky, right? So if the attachment is suspicious, then we can at least warn the user. We don't have enough confidence to reject the message because we haven't matched an exact virus sample, but we can at least tell the user that the attachment is suspicious. And for that, we can use the warning banners. As I mentioned before, even if there is no, even if the attachment was not malicious, or at least was not detected as malicious by the virus when the message was delivered, it's possible that it's because it was due to an out-of-date virus signature that eventually gets updated because, of course, we continually improve our signatures and we also purchase updates from antivirus vendors. So it's possible that at some point the antivirus would change its mind. So as I said before, we do a AV check at message open, and that would prevent you from opening the file. As I said, the reason is, of course, because the reclassification can take time. We want to reduce this window vulnerability. But so let's assume that the exploit is also not known when the user opens the message. So even the up-to-date virus check doesn't detect anything, right? So the user is not alerted and falls into the trap and opens the attachment, right? Well, the user is still not going to be compromised. The reason for this is that for a lot of very common file types like PDF and doc and so on, we have an embedded preview. This is just an HTML preview of the content that appears in the browser window. So that, of course, it's not vulnerable to PDF exploits, right? So to get exploited, finally, which unfortunately can happen, is that the user needs to also download the attachment. So let's go through a different path now that is usually taken by a phishing email instead. So in a phishing email, you're probably going to have some text that entices the user into clicking on a link, going on a website, and entering their password, and because they ask for the credentials, right? So this is probably going to be looking like a common service like Google, and it will ask for the passwords. So let's go over the scenario again. So first thing is that we are going to assume that the previous defenses have already failed. Not because they are more likely to fail for phishing, so we're talking about rejecting a delivery and showing all the various message bundles, right? Not because they are more likely to, but just because for brevity, right? We have defense in that, we know how those work, so let's move on to the phase that is different for now. So let's assume that the message gets to the user inbox, the user opens it, and that there is no warning related to phishing through banners, and therefore it clicks on the link, right? Like in this case, please click here to reset your password. Well, there are two things that can happen that will prevent the user from actually going to the site. The first is that in those gray areas where the backend classifier has low confidence about the reputation of the link, we can at least show a warning prompt. This will hopefully discourage the user about proceeding to the site, or at least alert him that he needs to be extra careful on this site. And the second thing is that we're going to do an up-to-date safe browsing check. Now, the browser also has Chrome at least, has a safe browsing blacklist synced on the client. And the one used on the redirector is more up-to-date and more comprehensive. The point is, again, being more up-to-date than the classification, which also would detect this, but that can take time. And even if the user gets no warning and enters the password, if the user has taken proactive steps, then even then, the account is not compromised. Right? So for example, two-step verification means that stealing the password is not enough to access the account. We had a webinar, I think, a month ago regarding how to set it up for your organization. And the other thing that we also discussed last month was password reset extension, which also needs to be set up for the organization or for the user. And it's very useful because it will reset the password immediately if it's typed on another site. Another type of phishing attack is auth, right? So the idea is that we're going to phish for auth permissions instead of credentials, and it's effective because users are less wary of delegating access or granting permission compared to giving out credentials. At least for enterprises, we can block these attacks by whitelisting which applications can ask for permission to the user. And then the final scenario that I want to go through is business email compromise. So this is very important for enterprises. And the idea of this attack is that the phisher entices the user to send confidential information directly to the attacker by replying to the message. So not by going through a site, but just by replying to the email. And let's go through a scenario and see how our defenses play with it. So let's assume that the user gets an email from a CEO. He's an employee, receives an email from the CEO and says, please, it's urgent, please give us the detail. Can you send them to us? And so first thing is that the users are not so easy to fool when they use Gmail, because most of these attacks require the sender to pretend to be in the user's organization. So one defense that is super effective against this is out-of-domain warning. We warn the user that this person is not in the organization. So obviously the user will immediately figure out that something fishy is happening. But let's assume, again, defense in depth, let's assume that this fails. So the user gets fooled and he presses send. The data is still not going to be, if the admin has taken proactive steps, the data is not going to be leaked anyway. We have this feature called data loss prevention that will run on outgoing email and scan it for sensitive information such social security number and bank accounts. So in this case, the user is typing is typing something, and this is an IBAN, a European banking account identifier. And if we have the proper DLP rules in place, we can stop this message from actually going to the phisher. So to recap, we went through these defenses. Hopefully now that you've seen them all one by one, this slide is less daunting. The main takeaway is, again, defense in depth. So many layers before a user can be exploited and can be attacked. And that's it for the talk. So we are going to be moving on to Q&A now after a very short break, I think around a minute.
Okay, so we're back. We have a few questions here, and remember that if we didn't go through your questions, we'll go through them offline on the platform. So the first one is, what should users be aware of regarding new trends in phishing and malware? Well, there's a growing trend of going to actual malware. Like as you get better at detecting phishing attacks, there's an ongoing trend that we're seeing of moving on to malware attacks. They're easier to hide. It's hard for us to execute every single malicious content and detect every single shady thing that it will do. Like imagine something that allows you to click on some elements of the UI. We can only do so much about that. So it's a growing thread. Our detection of content being downloaded into the user's computer and the ability to execute that in a safe environment for us to determine whether it's harmful. It's something we're investing heavily on. There's also, within the phishing arena, it's moving on to more spear phishing. Like they will invest in knowing a little bit more about the target and will try to convince them with specific information. Viral phishing has been going down, but the spear phishing, it's less in numbers, less prevalent in numbers, but they're much more damaging and much more likely to succeed. Like we've repeated during this talk, nothing replaces good awareness program and be constantly reminded of this for the users to never let their guard off. So second question, what are specifically the best steps to protect against spear phishing? Well, some of these things we covered in the previous talk. We recommend, strongly suggest you go ahead and watch that. But heed the warnings. We try our best not to make any of our warnings be a sort of cry wolf, so that they become like sort of unconsciously bypassed by users. So here we also need the collaboration of domain administrators to make sure that people heed those warnings. Data loss prevention, you need to configure it to work correctly according to the types of information you want to prevent from getting out of your organization. We'll look at your domain directory. If people are spoofing the name of the CEO, keep those updated. There's many things you can do to improve the security of your whole enterprise.
For this one, I think the most important one, even though it takes some effort, is set up two-step verification. If you really care about not getting spear phished, definitely buy a U2F security key. They cost, what, $20? You set it up, Google supports it, and that is, I think, the best way of preventing spear phishing, or at least preventing the attacker from accessing your account when your password gets phished. And if you're an enterprise, then the best thing to do is buying all your employees this key. Okay, so the third question is for mobile clients. Are there protections available there as well? Are all these protections available? Yes, most of them are. So sometimes the challenge, of course, is how do you show these queues in a reduced UI? But for example, the banners that we saw, they're all available. And I think all the stuff that is based on server-side functionality, like DLP or rejecting on delivery, and putting in the spam folder, that's also all available. I think of the ones that we saw, the only two that were not available were one was antivirus checking up to date, but of course on mobile viruses that are delivered through attachments are not as big of a threat because you cannot just execute an APK on Android, for example, and most malware ends up being for Windows. And the other one was preview, because we use the embedded previewer on your mobile device. For example, on an Android we use, I forgot what it's called, PDF reader. But anyway, it's of course on Android the applications are usually written in Java, or at least some of the parts are written in Java, and they are more resilient from exploits. That's all, right? Okay, yeah, that's all the questions. So please tune in next Tuesday. We're going to have more webinars. So I have the topics here. So we have data analytics and machine learning, IT infrastructure, and collaboration and productivity. So thank you for watching, and see you guys next time.
Thanks.